All right, so we're going to go back to solving equations. And this time we're going to look at solving one-step equations, but we're going to do a fraction style. All right, not to be confused with Gangnam Style. Dun, 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 dun. Great song. All right, so same concepts are with solving equations when we have a fraction. I just want to go over with solving with fractions so you're comfortable that way. So we've talked about solving equations with whole numbers. We've talked about adding and subtracting and multiplying and dividing fractions. Now we're going to put those two things together. So we're going to first start by solving using addition slash subtraction. And with solving equations, our goal, very similar to our goal when we talked about solving equations the first time, is to get the variable by itself on one side of the equal sign. And sorry, you may hear my son in the background. I apologize. Um, so again, same goal. Get the variable by itself on one side of the equal sign. If the variable starts on the right side of the equal sign, get it by itself on the right side. If the variable starts on the left, get it by itself on the left side. Now, how we do this, how we accomplish our goal, is we are going to solve using inverse operations. So just like when we solved equations the first time, same thing. We're going to solve using our inverse operations. So let's talk about the additive inverse. The additive inverse is subtraction. So when you see addition, subtract to get it by itself. And the subtraction inverse is addition. So when you see an equation that has subtraction, and then how we know we're done? We are done when the variable is by itself. All right? So again, we know. So we're like, I am done because the variable is by itself. Now there's something we're going to add here. So I want you to put a star or an asterisk, something so that you know. You're like, hey, this is important. If the denominators, remember we're working with solving equations fraction style. So if the denominators are not the same, you must find common denominator before you solve. Right. So again, put stars, do something, highlight it. I don't know, put big red circle, write it in something so that it stands out. This is something that's very important here. All right. So if the denominators are not the same, you need to make sure you make them the same before you solve. So let's look at some examples. So let's look at example number 1. Example number 1 is x plus 2/7 equals 5/7. So first let's look. Are the denominators the same? Yep, they are. They're both 7. So we don't need to worry about finding common denominator. Now we go through. Our goal is to get the variable by itself. The variable is an x. And we're going to solve using inverse operations. So we see addition. So we want to use the additive inverse, which is subtraction. So we're going to subtract 2/7 from both sides of the equal sign. Because again, our goal is to get x by itself. We use the additive inverse, which is subtraction. So we're going to subtract 2/7 from the left, And if I subtract 2/7 from the left, I got to subtract 2/7 from the right. So we're left with x equals, well, what's 5/7 minus 2/7? Well, we just do 5 minus 2, which is 3. And our denominator stays the same. So x is 3/7. Again, I could check to see if I did this properly. All I do is I plug 3/7 back in for x. So you get 3/7 plus 2/7. Well, 3 plus 2 is 5. We're good. Let's look at example 2. Let's zoom in a little bit. All right, so example 2. Y plus 2/3 equals 7/9. All right, let's look at our stars. If denominators are not the same, we must find a common denominator. Well, here we have a 3 and a 9, so they're not the same. So we need to find a common denominator. So before we do any math, we have to find the common denominator. You can either do the cross multiplying, or you can notice that 3 goes into 9. So really I only need to change this. So I'm going to multiply this by 3 to make it 9. And if I multiply the bottom by 3, I'm going to multiply the top by 3. So we're going to get y plus 2 times 3 is 6. 3 times 3 is 9 equals 7/9. Boom. Now we have common denominator. Now we do the math. Subtract 6/9. Subtract 6/9. These 6/9 go away. Y equals 7 minus 6 is 1. Denominators are the same. 1/9. Boom. We can plug 1/9 back in. Wouldn't necessarily be the original one. It would be our new one. So 1/9 plus 6/9 is 7/9. So remember, this one we didn't have common denominators. I had to find a common denominator, then do the math. This one we had common denominators, so I just got to do the math. All right, let's talk about example 3. A minus 3/5 equals 1/5. Let's look. Do we have common denominators? We do have common denominators. Since we have common denominators, guess what? I get to just do some math. I look to see there's subtraction going on. So the subtraction inverse is addition. So we're going to add 3/5. If I add 3/5 to the left, I got to add 3/5 to the right. These go away, leaving me with A equals. What's 1/5 plus 3/5? Well, 1 plus 3 is 4. Denominators stay the same. We get 4/5. Let's go to example 4. Example 4. M minus 1/3 equals 1/2. So if we look here, do we have common denominators? Nope. So guess what? We got to find a common denominator. This one works where we can just multiply by the opposite denominator. So we're going to multiply this side both by 2, this side by 3. So we get m minus 2 times 1 is 2. 3 times 2 is 6. 3 times 1 is 3. 2 times 3 is 6. Now we have a common denominator. So guess what we get to do? Let's solve. We see subtraction, so we do the opposite of subtraction, which is add. And we add 2/6 to both sides. Add 2/6. Those go away. M equals, what's 3/6 plus 2/6? Well, 3 plus 2 is 5. Denominators stay the same. We get 5/6. Boom. So this is solving equations, fraction style. All right. Same method. The whole goal is to get the variable by itself. But this time we're dealing with some fractions. We need to make sure Check to see, are the denominators the same? If the denominators are the same, go right ahead, get the variable by itself. If the denominators are different, you need to find a common denominator, then do the math. All right. Hopefully this helped. Hopefully you got this all copied down. And we'll do some clarification right afterwards.